Predicting products from acid-base word reactions. It tells you the steps for each one. First, write the formulas for the acids and bases listed. Then complete the reaction by predicting the products formed, balance the equation if necessary, and then name the products that are formed. So in this first example that's done for you, we took hydrochloric acid plus sodium hydroxide, and that's all it would have given you at the beginning, like these. And then we know that hydrochloric acid, since it starts with hydro, would be a binary acid, so I know it's going to be hydrogen and chlorine, which hydrogen has a +1 charge, chlorine a -1, and so I can put them together to make HCl. Sodium hydroxide is sodium, Na, and hydroxide, which is OH, and I put them together as well. Sodium is a +1 charge, hydroxide a -1, so they already cancel out and I don't have to crisscross, and so I get NaOH. So once I had this, HCl and NaOH, I know that the H and OH will combine together to make water. And I'm left with Na and Cl. And I know already this had a +1 charge and this had a -1 charge. So you put the +1 and -1 charges together, they already cancel out, so I get NaCl. Once I had NaCl and H2O written down, I can check to make sure it's balanced, and it is. They're the same number of each element on each side. And then I can write the names. NaCl is sodium chloride. IDE ending means that chlorine is in an ionic compound with the other element. And then water is H2O. So let's do the first one together here so that you get a better idea of how this is going to work. So nitric acid, it doesn't start with hydro, so I know I'm going to use the rules for my ternary acids. And it's nitric acid, and I know ic came from an 8 ending. So that means I have nitrate here in my acid. So I find nitrate, which is here on my polyatomic ion chart. It has a -1 charge and it's NO3. So I know I'm going to have NO3 with a -1 charge, and I know that acids always begin with hydrogen, which has a +1 charge. +1 -1 already cancels out, so I don't have to do my crisscross method, and so nitric acid is HNO3. I just put the H and NO3 together because their charges already cancel out to neutral. Then I'm going to say plus calcium hydroxide. Calcium, when I look on my periodic table, it's Ca. It's in group 2, so I know it has a +2 charge. So Ca with a +2 charge, and hydroxide I know is OH with a -1 charge. Now +2 and -1 don't cancel out, so I do need to cross these over. So I'll have Ca gets a 1 subscript, but I don't write ones, and OH will get 2 as a subscript, and I put it in parentheses here because there are 2 of them. Here I don't have OH in parentheses because there's only one OH, but as soon as I have to bring down a subscript for it, I do need to put OH in parentheses, because if I don't have parentheses, then I'm saying I have an O and 2 H's, but that's not the case. I need 2 O's and 2 H's here because hydroxide is OH together. Then I'm going to draw my arrow, and I'm going to make the products. Now I know that H and OH will form water, so I'm going to ignore those for now, and what I'm left with is Ca and NO3. I always write my positive ion first, so I know I'm going to put Ca first. So when I write out my compound, it's going to be Ca, and then I need to determine, do I need to cross over my charges? And I do, because a +2 for Ca and a -1 for NO3 do not cancel out. So my 2 will cross over to be the subscript for NO3, and the 1 will be the subscript for Ca. Again, I don't write ones as subscripts, and I need NO3, and I need 2 of them because that's going to cross over. So I'm going to put NO3 in parentheses so I can put a 2 saying I have 2 NO3s. So I've made that product, which is the hardest one to make because, remember, my other product with H and OH will always be water. So there's H2O. At this point now I need to balance the equation because it's not balanced. I have 1 H here and 2 more H's here, gives me a total of 3, and here I only have 2. So I know that this isn't balanced. So what I'm going to do is I'm first going to fix this polyatomic ion that's not balanced. I have one NO3 here and I have two NO3s here. So I know I'm going to need a 2 in front of HNO3 so that I have 2 nitrates on the left, just like I had 2 nitrates on the right. This gave me now 4 total hydrogens on the left-hand side, 2 H's here and 2 H's here. So in order for me to have 4 hydrogens on the right-hand side, since I only have 2 here, I need to multiply by 2. So now I have 4 H's on the right-hand side, just like I do on the left. And now I have 2 O's here and 2 O's here, and it balances out. So you can write 1s in these spots if you'd like, though it's not necessary. Now that I've balanced my equation, I can now name my products. This is the last step for each of these problems that you have to do. So I have, this is a salt, so I'm going to name it as a salt. Ca is calcium, and NO3 is nitrate. Because I'm looking at an ionic salt here, it does not matter how many nitrates I have. I just write calcium nitrate, and I don't have to worry about having 2 of them. In ionic compounds, we don't do the prefixes like we do in covalent compounds. And then plus H2O is always water. And number 1 is done. You're going to do the same thing with these, and don't forget that this number in parentheses here, this Roman numeral, tells you the charge of the element before it. So this 3 tells me that iron has a +3 charge, and then all you have to do is combine it with hydroxide to make your base. So go through these, and if you do get stuck or have any questions, please come ask.